today's lab, we are going to do a PSK modulation, or you can say phase shift keying modulation. So again, you need to go to Simulink, click Simulink, click the blank model. It will open, and let's see. Let's say we name it as your PSK new. Save it. Okay, sorry. I left a gap between them. So it's PSK new. Click the library browser, and in the library browser, you can search whatever we require. So first of all, I'll just put everything what we require there, and one by one we will send it to PSK new. Sine wave, and we need pulse generator. Then we need a switch. I'll explain why we need these things. Then we'll need a constant. Then we need a product. Then we need a mux. So now we have all components required by us on the model. Mux, product modulator. We have constant. We have a switch. We have a pulse generator. We have a sine wave. Now, one thing is missing is your scope. So we need to now search a scope. Scope is basically your oscilloscope. Now we have all of them. Okay. Now we need to arrange them in the way which we are going to use them. So this is your sine wave, your pulse generator. Okay. So you have a sine wave, and then you have a switch here. Okay. And then you have a constant somewhere here. I'll explain you how we are going to use them. And then you have a product here. Mux between your this oscilloscope. Let's say, so now let's start doing the connection first. So it will go to this. Then pulse generator will control your waves coming to it. And then you have a constant. The constant output will go to the product modulator, and this will be connected to a sine wave. Basically, we need an inverted sine wave, and then it will be here. Then this output will go to the mux. This will go to the one of the output of the mux, input of the mux, sorry, and this will be connected to your pulse generator, and then it will be connected to your, sorry, it's better we have more input to the this, and we have this connected here. Then we have your sine wave connected here, and we can also look at what's the wave coming out of this. Okay, so now we need to set the parameters. And once we have output available, I'll explain you why we are doing this, why we are doing this. Okay, then you need to go. It is your amplitude is same, so you need to have a frequency of 4 pi and a sample time of 0.01. Apply. Okay, then pulse generator amplitude remains same. Your period is 2, and let's say width now we are doing is 50%. Apply. Okay, constant, I'm making it equals to -1. Explain why we are doing this. So we have this, so we don't have to change anything else. Now you have a sine wave coming from this side, and a pulse generator is here. And if you say that this -1 is inverting the polarity of the pulse wave, so we are doing PSK. So what happens in PSK is that when you have a positive pulse, the input signal passes as it is, and when you have a negative pulse, the input signal is reversed, or you can say it is shifted by 180 degrees. So in order to bring that thing, we are using it. Now this switch is working depending upon the value you are generating here. So if it's greater than 0, this is greater than 0, then this wave will pass. Means the value of pulse generator is positive, then this will pass. If the value of pulse generator is less, then this will pass. So I was explaining you that when this amplitude needs to pass, then your pulse output is input should be positive, means say greater than 0. When this is a negative going wave, then this will pass. So this is the use of this switch. Then we have a mux. Mux is basically used to pass one of the wave at a time. You know what is multiplexer is, and then scope. Now, if we run it, we have 3 inputs to this. So if you see, then it is basically showing you that when it is positive, this is the use of mux. So mux is basically showing you both the waves. So this is when it is positive, then the same wave is passing. When the negative comes, means negative comes, so negative is coming somewhere here, here the negative is coming. Or if you want to get you a better clear idea of this, we can change the number of inputs to it, or let's say make it 4. Okay, so now we have one more, and we can look at the pulse also. So now we run it again. Let me close it. We need to now go here, and we need to make it 4. So now you can see that this is our waveform. When it's a 50% pulse, you can say on or off time is your 50%. So this waveform, the pulse generator is providing us the wave which is high for 50% of the time. So when this is high, this waveform passes as it is. When this is low, 180-degree phase shift, and a reverse version of it will pass. So how it's happening is that when this is giving us positive value, this waveform is passing as it is, and when it is negative due to this less than 0 and greater than 0 term. This waveform, which is reversed by us, -1 into sine wave, we are getting it from here, and it is passing. If you want to see, have a more closer look, just change your number of input ports more, make it 5, and you can look at this one also. And you run it again, and then you see you need to but create a place where you can see the fifth one. It has only 4. So sorry for that. It has so you can see that this is the negative pulse created by it. So this is positive, this is negative, or you can say that the output we are getting here, it is this waveform. This waveform is that one. So this is positive going sine wave, and then we are multiplying by -1. So it is changing. So when it is positive, then this waveform is passing. When it is negative, means this is negative. Then this waveform is passing. So it's working that way.